Good morning everyone. Today, we will be discussing alcohols, phenols and ethers. We'll go over nomenclature, common names and IUPAC names for these substances. Let's get started. Naming alcohols, phenols, and ethers requires understanding the chemical composition of each. Alcohols contain the hydroxyl group, which has the chemical formula O. Phenols also contain the hydroxyl group but in addition feature an aromatic substituent group. Lastly, ethers contain an oxygen atom with two alkyl or aryl groups on either side. Alcohols are organic compounds containing the O functional group, represented by the general formula RO, where R represents an alkyl group, a hydrocarbon chain. For example, when R is a methyl group, the alcohol is known as methanol following IUPAC naming conventions. This includes the root word, plus and an OL. Thus, the root word is meth, forming its IUPAC name of methanol. Ethanol is a kind of aliphatic alcohol, and is the most widely used alcohol. It has the formula ethyl hydroxide, and contains a hydroxyl group attached to a carbon atom. It has many uses, such as a solvent in several industries. 3-propyl alcohol, also known as propan-1-OL, is an organic compound whose formula is represented as H3CCH2CH2OH. It is a type of alcohol used in chemical reactions, and is also a solvent employed in the production of paints, lacquers and varnishes. Alcohols, phenols and ethers are an important group of organic molecules. An example of an alcohol is iso-sec-propyl alcohol, also known as propan-2-OL, which has the form H3CCHCH3OH. The hydrogen atoms of this molecule are numbered 1, 2, 3 and the oxygen atom bonded to hydrogen 3 has the hydroxyl group, O, which is a trait common among alcohols. Alcohols, phenols and ethers are chemical compounds that possess properties which make them suitable solvents for a range of uses, from pharmaceuticals to industrial and research applications. A prime example is N-butyl alcohol, otherwise known as butan-1-OL, which is a 4-carbon alcohol very commonly used in the pharmaceutical industry. This chemical compound is highly volatile, thus necessitating strict safety guidelines for the correct utilization of the substance. Sec-butyl alcohol is a clear liquid chemical composed of 4 carbon atoms, 3 hydrogen atoms and 1 oxygen atom. Its molecular structure resembles a straight chain, with the oxygen atom at the end. It is utilized in the production and manufacture of fragrances, fuel and various chemicals. Isobutyl alcohol is a clear, colorless organic compound with chemical formula H3C, CH, CH2O, CH3. It is also known as 2-methylpropane-1-OL. Its uses include serving as a solvent or a feedstock for organic synthesis and being a popular ingredient in perfumes and other fragrances. Slide discussing alcohols, phenols and ethers mainly focuses on neopentyl alcohol and 2,2-dimethyl-propan-1-OL. Both of these molecules have peculiar properties and reactivities that come into play. This stuff is useful in many aspects of chemistry, and knowledge of their properties can provide insight into their potential applications. Alcohols, phenols and ethers are an important group of organic compounds with special properties which are applied for diverse functions, for example as solvents, fuel components and preservatives. Trimethylpentan-3-OL is a member of this group of compounds and is frequently utilized as a solvent. Its molecular structure consists of 3 methyl groups connected to a pentane backbone and moreover an additional O group at the end. This composition makes it convenient for multiple purposes, both for industrial and scientific purposes. The molecules of interest here are alcohols, phenols, and ethers. These molecules share similar structural properties, but differ in the functional group that is present. In this table we can see how butane is structured as a 2,3-diol. Its hydroxyl groups are numbered 1 and 2, and the carbon atoms are numbered 3 and 4. This is just one example of the variety of molecules found within these groups. Pentane 1,2-diol is an organic compound belonging to the class of alcohols, phenols or ethers. It is composed of 5 carbon atoms connected by a ring, and 2 hydroxyl groups, granting it the ability to react with both acid and alkali. This compound is extensively used in the manufacture of surfactants and detergents, and is also employed as a thickening agent for paints and lubricating oil. The molecule 4-chloro-2,3-dimethylpentan1-OL is an example of a chlorohydrin. It has one chlorine atom, symbolized by Cl, substituted for the hydrogen atom at the 4th carbon-carbon bond. The molecule comprises of 5 carbon atoms, 14 hydrogen atoms and 1 chlorine atom. An important chemical compound known as 3-bromo-HEX2-EN2-OL is composed of an alcohol group, an ether group, and a phenol group. Its formula, BrH3CCHCHCH2CH2CH3OH, consists of 1 atom of bromine, 3 atoms of hydrogen, 1 atom of carbon, an unsaturated hydrocarbon chain, and a hydroxyl group, making it an essential building block in a range of chemical compounds. This compound is vital for many chemical processes. As seen from the slide, the number of possible isomers of alkyl alcohols plus ethers, and ethers, can be found by subtracting the respective equations. Organic chemistry requires students to understand this concept. Thus it is important to practice and review the equations to be able to apply them accurately. Grasping the distinctions between these molecules can seem intimidating, however guidance from the right sources can help one develop a firm understanding of them. We are looking at a slide which focuses on alcohols, phenols, and ethers. A chemical structure with 4 carbon atoms is seen at the top of the slide and 4 potential IUPAC names for it are written below it. The correct name for the structure is 2-chloro-3,4-dimethylpentan5-OL. It is important to keep these terms in mind as we proceed. The slide is showcasing the IUPAC nomenclature for 4 molecules composed of 1-bromocyclohexanol, 5-bromocyclohexanol, 4-bromocyclohexanol, and 3-bromocyclohexanol with an OH group and bromine atom. It is significant to be aware that the location of the O group and bromine atoms sets these molecules apart. Alcohols, phenols, and ethers are all organic compounds, and they can have a variety of different isomers. One way of classifying these isomers is by noting how many carbon atoms they have. For example, alkyl alcohols can have anywhere from 2 to N1 carbon atoms, with N2 or N1, or even N+1 being possible isomers. As you can see, the number of isomers for these 3 compounds can be quite complex. This slide presents the structure of functional groups for alcohols, phenols, and ethers. Alcohols are organic compounds that contain a hydroxyl group, which is a molecular fragment with an oxygen and hydrogen atom bonded together, as part of the molecular structure. Phenols are compounds which contain a hydroxyl group bonded to an aromatic hydrocarbon group. Ethers contain two alkyl groups connected by an oxygen atom. Therefore, these compounds are inorganic and don't contain a carbon-hydrogen bond. Organic compounds methanol, phenol, and dimethyl ether have distinct structural forms and physical properties. Methanol is formed of one carbon atom, one oxygen atom, and 4 hydrogen atoms, in a single ring. Phenol consists of one oxygen atom, 6 hydrogen atoms, and one benzene ring with a hydroxyl group. Dimethyl ether is composed of 2 methyl groups attached to an oxygen atom. These molecular arrangements create a variety of unique characteristics, which can be employed in different applications. Looking at the difference in bond length and angle between alcohols, phenols and ethers, it is evident that phenols have a shorter and slightly different bond length compared to alcohols, and a slightly different bond angle. This is a result of the partial double bond character in sp2 carbon attached to the O group of phenols. Having a clear understanding of the distinctions between these molecules is essential for the study of organic chemistry. For alcohols, phenols and ethers, the order of bond angle is alcohol, phenol, ether. The order of bond length is alcohol or ether longer than phenol. This difference is due to the larger size of the alkyl groups around oxygen. Methanol has a range of uses in the industrial realm. It serves as a solvent for oils, fats, gums and related substances, a cleaning agent and a component in perfume production. Additionally, methanol is used as an antifreezing agent. It also functions as a precursor to chloromethane, dimethyl sulfate and formaldehyde in their respective syntheses. Ethanol is an extremely useful and significant chemical. It can be used as a solvent in substances like dyes, oils, perfumes, cosmetics and drugs, as well as in production of motor fuel, by blending 10 to 20% ethanol and petrol, and in production of chloroform, iodoform, acetic acid and other materials. Furthermore, it has a long history of being used as an alcoholic beverage. Additionally, ethanol has numerous medical uses. It is an excellent topical antiseptic and is known to improve many skin issues. As we can see from the text, power alcohol is made of 20% absolute alcohol and 80% petrol, and rectified spirit is a mixture of 95.6% ethyl alcohol and 4.4% water. Absolute alcohol is 99% pure ethyl alcohol with not more than 1% of water. Alcohols are organic compounds containing a single hydroxyl group attached to an organic carbon atom. Boiling points of alcohols are usually higher than alkanes of the same molecular weight, as a result of stronger intermolecular hydrogen bonding. This is the key factor that explains the increased boiling points of alcohols. Therefore, choice C, intermolecular hydrogen bonding, is the correct answer to the multiple choice question. We are examining the uses of alcohols, phenols, and ethers as antifreezing agents. The 3 substances we will be looking at are methanol, ethanol, and propanol. Methanol is beneficial for this purpose since it can lower the freezing point of a mixture without affecting the boiling point too much. Ethanol can also be used as antifreeze, though its high flammability limits its applications. Finally, propanol is employed as an antifreeze, however the amount used is limited due to its toxicity. Ethanol and propanol are both alcohols, typically used in alcoholic beverages. Ethanol is the most popular, since it is the alcohol commonly found in beer, wine, and spirits. Propanol is an alternative type of alcohol that has become more widely used as an alternative to ethanol. Both ethanol and propanol have fewer health risks than other types of alcohol, like methanol. Answer. Option C. Both A and B is the correct answer to this question. The CO bond in phenol has lesser length due to its partial double bond character and the sp2 carbon atom attached to the O group. Thank you for watching.